Hi everyone, welcome to JEE MAX, JEE Main's Advanced Extreme Series. Welcome to season number 2 of JEE MAX, and through this season we're completely concentrating on a particular topic which is very important for JEE Mains and Advanced. Of that, complex numbers is one, and so far successfully we have completed 34 lessons in complex numbers. This is lesson number 35. And my friends, please don't worry, I'm giving all the links of previous lessons also. That's why please check the description box there. I'm providing everything for you, and moreover that apart from that, I'm providing very good assignments and question papers also, because complex numbers is an important topic for competitive examination. And moreover, from lesson number 27 we are completely concentrating on solving the problems of integrated textbook exercise 4.3 of complex numbers, and in lesson number 35 from exercise 4.3 we are concentrating on the 18th problem, and in the 18th problem there are 4 problems are there. One by one we are concentrating. Each and every problems are similar models, and every question they have asked in one of the JEE advanced examinations also. That's why every question and the strategy behind the questions are very important. Again, I am repeating, please solve all the workload examples that are given in the integrated textbook. That knowledge is very important. If you master the integrated textbook alone, you can do wonders in the competitive examinations. This is the preliminary area, primary area, important area. Okay, now coming to 18th problem number 1. See, the area of the triangle whose vertices are the roots of. Again, it is what? In the case of solving the roots. Once after getting the roots, then finding the area is nothing for you. How to get the roots? So here I am again applying my strategy. So how I am simplifying that? See, I am adding. I am taking this as, I can write this as what, that 2i I can write that as I plus I, and this I can write z cube plus I plus I into again z square plus 1 I can write it, and this I can again write it as minus I cube, because minus I cube is nothing but plus I. The reason is very simple, because this is in the form of a cube minus b cube, therefore a minus b d square plus ab plus b square I can write it. So the thing is, after a simplification of this, I can get my roots of the equation as z is equal to I 1 minus I minus 1 minus I. You know it very well. But z is equal to I means what? That is nothing but 0 plus 1i. That is, this is the coordinate 0 comma 1. Z is equal to 1 minus I. Coordinates are 1 comma minus 1. Z is equal to minus 1 minus I. Then coordinates are minus 1 minus 1. And you know it, right? Area of the triangle is half modulus x1 y1 1, x2 y2 1, x3 y3 1. Simplify this, you will get answer as 2 square units. Simple. So finding the area, see, that's why it is also the mixed problem. Though the question is from complex numbers, see, 3 areas were covered. One is solving the equation. There is one part. Second part is with that we are applying the complex numbers. I mean coordinate geometry, area of the triangle concept, determinant concept. That's why this kind of mixed oriented problems are always important. Now coming to 18th second problem. This is the most important problem, and several times the same question was repeated in advanced examination also. This is one of the best example. Even in IIT examination also, the same models were repeated. For that, to support that statement, this is one of the best examples. Now read the statement properly. A and B are what? Real numbers lie between 0 and 1. That means 0 less than A comma B less than 1. That is the given statement. And moreover, Z1 is A plus I is given, Z2 is 1 plus BI is given, Z3 is 0. They form what? Equilateral triangle. They form what? An equilateral triangle. Find A and B. Equilateral triangle means what? Suppose if ABC is an equilateral triangle, then what is that? AB equal to BC equal to CA. That means mod of Z1 minus Z2 equal to mod of Z2 minus Z3 equal to mod of Z3 minus Z1. So solve one by one. You can get some relations. See, here I am doing the same job. See, here I am doing the same job. But it requires some patience and solving the problem in quick manner. So let ABC be the equilateral triangle such that A equal to Z1, B Z2, C Z3. Therefore, AB equal to BC equal to CA. So this one. First, equate the first two. So after simplification of this one, 1 plus a square minus 2a minus 2b equal to 0. After simplification of this one, you can get it. So again, by equating second, after again you can get after simplification of this one, a equal to b. The reason is not write, don't write that a b equal to plus or minus a, because a and b are lie between 0 and 1. That's why boundary conditions are important. Boundary conditions are important. So ultimately a equal to b, and from equation 1, 1 plus a square minus 2a minus 2b equal to 0. Since a equal to b, you substitute there. Since a equal to b, you substitute there. So that becomes what? A square minus 4a plus 1 equal to 0. So a equal to 2 plus or minus 3. But a and b are lie between what? Again, 0 and 1. So 2 plus root 3 is not a number which lie between 0 and 1. So a equal to 2 minus root 3. So ultimately, a equal to 2 minus root 3, which is nothing but what? My b. So I got the values for a equal to b equal to 2 minus root 3. This is the question, and this was the question several times. The same model was repeated in the IIT advanced examination also. Okay. Now coming to 18th third problem. Read the statement properly. Z1 square plus Z2 square minus 2 Z1 Z2 cos theta equal to 0 is given. Then show that origin Z1 Z2 form vertices of the isosceles triangle with vertical angle theta. So what I am going to do is, so ultimately suppose origin Z1 Z2 are vertices of an isosceles triangle with vertical angle theta is given for me, and getting that relation in terms of cos theta is very easy. But here converse is given. This is somehow challenging. But anyhow, how to do? See, what I am doing is, here this is suppose my triangle, and these are vertices. One is origin and another one is a Z1, b Z2. Okay, and moreover, this is we have to show that origin is one of the vertex, is an isosceles triangle with vertical angle theta. This theta we have to find. So actually from this triangle, I am applying my cosine rule for what is cos theta. The cos theta is what? OA square plus OB square minus AB square by 2 OA OB. Isn't it? This is my cos theta. Right? So here what I am doing is, see, first this is the given equation for me. Let OAB is a triangle, and I have written my equation. This is another beautiful step. What I am doing is, I divide entire equation with Z2, and just you consider Z1 by Z2 as Z. So simply I got this as equation in Z. After simplification, you got Z as cos theta plus or minus I sin theta. That is mod Z is equal to mod of Z1 by Z2. That is equal to mod of cos theta plus or minus I sin theta, which is 1. So mod Z1 is equal to mod Z2. That means this length, this side length and this side length both are same. So this length and as well as this length both are same. And this is what? Theta. So now what I am doing is, the triangle is isosceles. Enough. Not necessary to do anything more. Clear? Because if any two sides are equal, if I have proved it, that triangle become automatically what? Isosceles triangle. For that, here, this is the brilliant technique that I have applied. So from the given equation, I divided on both sides with the Z2 square, and I have converted that into entire equation a quadratic in Z, and I got Z, I got complex number Z as what? Cos theta plus or minus I theta, but mod Z is equal to mod of Z1 by Z2. Therefore, ultimately I have shown, because this is one of the litmus tests. How can I show that the triangle is an isosceles if any two sides are equal? So I proved that Z1 is equal to Z2, therefore obviously that triangle is what? Isosceles. This is one of the important concepts. There are several methods, of that this is one. Okay. Now coming to 18th fourth problem. Again my friends, find the nature of the triangle with vertices. Whenever root 3 involved, automatically the triangle is nothing but an equilateral. That's a different story. Again here also, some relation has been given for you. To prove that as an isosceles or equilateral or something like that, or if all the sides are equal, or if all the angles are 180 degrees, 60 degrees, then automatically the triangle become the equilateral. So with given help of the information, what I am doing is, see, so this is the given concept. So take modulus. So ultimately I got mod Z1 minus Z2 is Z3 is equal to mod Z2 minus Z3. So these two sides are equal. Suppose this is my triangle. Suppose this is my triangle, say AZ1, BZ2, CZ3. Okay, and here these two lengths Z1 minus Z2 equal to Z2 minus Z3. These two lengths are equal. Z2 minus Z3. These two lengths are equal. Say for example. Okay. So what is cos pi by 3? What is cos pi by 3? Cos pi by 3 is equal to what? 1 by 2. That is equal to this. I can get it. So with this, what I am doing is, after cos pi squaring and simplification and by using equation 1, I got remaining two sides are also equal. Okay. So here what I am saying is, suppose this length as well as this length are equal. These two sides are equal. Now I find that what, suppose I am finding this as what, because why I am finding cos pi by 3 only, because the reason is because mod Z1 minus Z3, this side length and this side length is equal. See my friends, actually here with this we can write this. I can write it as e power 1 into e power I pi by 3. That means angle between these two is pi by 3. That's why I have applied this by applying CONI'S theorem, because mod Z1 minus Z3 means this length is equal to mod Z2 minus Z3, this length. And by CONI'S theorem, this indicates what? Angle between these two is pi by 3. Here I applied what? Cosine formula. By cosine formula, what is cos C? Cos C means cos pi by 3. Actually, this is what? Cos C. What is cos C? AC square plus AB square minus AC square plus BC square minus AB square by 2 AC into AB. And here my angle between these two sides is pi by 3. I applied it and I simplified this. I got remaining two sides are also equal. So all the three sides are equal. That means what? The triangle is equilateral. So with the help of this information only, by CONI'S method, I got this one. Okay. That's why here, see, that is pi by 3. Because this is given for me. I applied this. Clear? Next. If you like this video, please share and subscribe, and don't forget to check the description and don't forget to press the bell icon. And we will meet with the next video.